Okay, now let's talk about the inverse of a function as a transformation. So that's basically the same idea as a reflection. Okay, you treat it just exactly the same. Just a review. The notation for the inverse of a function is the f to the exponent of -1, but it is not exponent. I want to make sure that that is, you understand that that's just a notation, f inverse of x. All right, and in terms of the geometry of that is that it's just that the function or the graph is reflected over the line y equal to x, and what it means in terms of the coordinate values is that the coordinates are being interchanged. So the x value becomes the y value becomes the x value. And look at this example. Suppose I have this linear function f of x equal to x plus 3, and if I want to find the inverse of that, I just switch x and y. You see what I've done here? X and y. Remember that the original, this also can be written as y equal to x plus 3, right? So I just switch the x and y. Simple as that. You switch them around and then rewrite the equation for y, and sure enough, in this case, y will be equals to x minus 3, which is the inverse of the original function. When you graph these two guys, the green graph is the x plus 3. So this is the x plus 3, y equals to x plus 3, the original function. The purple graph is x minus 3. So y equal to x minus 3, and they are inverse of each other, and they're reflected over the diagonal line y equal to x. And notice that every single coordinate on y equal to x plus 3, when you switch the x and y values, you'll get the graph of the inverse. So just as an example, we have the y-intercept is 3. Well, the y-intercept is 3, but the x-intercept will be 3 for the inverse. Okay, and you can actually choose any point, like any point at all. So this point right here, for example, up there, that's 2, 5. Okay, and 5, 2 must be on the graph. Guess where that is? 5, 2 is on the graph of the original. So 5, 2, which is right there, that's the inverse, 5, 2. Okay, and you can map every single one of them. Now, in terms of the transformation, that actually comes first. Okay, it's just a reflection. You got to do the function transformation first. So if you have x, y, and it's going through the inverse transformation, that right away you got to do this to it. The y value becomes the x value, the x value becomes the y value. You just interchange them. Okay, very good. So let's suppose we want to find the equation of the inverse of a function, and the function is supposed to be given to you. It doesn't matter what it is, but the process in terms of algebraic operation is that you just want to go through and basically interchange x and y and then solve the equation again for y. So I'm just going to replace f of x with y, and now I'm going to interchange x and y. Just simple as that. Okay, so this becomes x equals to 2 times root y minus 1 plus 1. That's the first step. Very first step you got to do. And then from this point on, it's just algebraic operation. You just have to go ahead and isolate y, and by doing that you get x minus 1 2 times root y minus 1. So I'm just basically isolating y. Got rid of the 2 if you want to, or you can actually do the a square. Regardless of how you will do it, doesn't matter. At the end you have to deal with that. So that would be x over 2 minus 1/2 equals to root y minus 1. And then in this case you have to square both sides, because you want to get rid of the square root and you want to get the y value on its own. You get y minus 1, and in here you get x divided by 2 minus 1/2 all squared. Okay, you can expand it if you want. That's not a big deal, but we are solving for y. So at the end we're going to bring y. So that would be y equal to, we're solving for y equals to, we're just going to move the x, sorry, the -1. So it would be that plus 1. Okay, and in this case you can go ahead and expand if you want, and then you rewrite f inverse of x is x minus 1 over 2 all squared plus 1. Okay, And if you want to expand that, you go ahead and expand it, and you should get something like what I've got. But it's not important in this case. I'm hoping that you know how to do the algebraic operation. Okay,